So today my talk is going to be on React hooks and why we need them. And since we've got such a large audience here, I'd like to get a show of hands for everyone who's used React before. And keep them up, put them down if you've never used hooks before. Okay, so we don't have any hooks people here. That's good. Might be a complete waste of everyone's time. And for those of you who have used hooks, hopefully you still learned something. I'm Chris Parton. I live and work in Wollongong as a software engineer at Southern Mobile. And Southern Mobile is a company where everyone's remote, works from home, and we all contract to the company. And being a contractor means we get to make our own hours, and we work on all kinds of different projects, front end, back end, database, mobile, bit of UI design, bit of infrastructure, just the whole gamut really. So if anyone is interested in that kind of thing, feel free to hit me up on Slack or in person, and we can have a chat about it. In my spare time, when I'm not screwing my employer, you'll find me trying to keep up to date with web technologies and sticking LEDs on anything that stands still long enough. Christmas coming up is kind of my time of year. Now, before we look at React hooks themselves, I wanted to just take a moment to kind of whinge about the past before we move to the future. And I want to start by going back to 2006. That's me. I actually checked the metadata on this picture. This is on my 15th birthday, and this was taken 13 years and 15 minutes ago, I think. So pretty much as I was walking up here, I was holding up pizza. Thank you. And the reason I wanted to go back here was to show off my amazing design skills and began my web journey. I think that was made in Paint, and it was like a 2 megabyte bitmap image, but it's still leaner than the average website today. And web design in 06 was very different than what we do today. We have our developers who use ugly and crude tools to create some static HTML. And then maybe if you were lucky, you would see a little bit of JavaScript sort of get sprinkled on top for like modals, that kind of thing, image carousel. And typically, they weren't actually just creating HTML, it would have been PHP, but the same still applies. Now, fast forward to 2019, and the whole landscape is radically different. We've got huge companies pouring millions of dollars into these awesome web applications, like fully fledged streaming, chat, social media with built-in chat, very sophisticated. And the way we do this is with lots and lots and lots of JavaScript. HTML at this point is little more than just a target to aim this bombardment of JavaScript at. And then the way we write the JavaScript itself has changed as well. So back in 06, you were doing a lot of manual DOM manipulations, sticking variables on the window object and all that sort of thing. But now we have frameworks like React that cater for the complexity that we need to include in our applications to make our customers happy. And even our frameworks are changing to meet that complexity, which is why we have hooks. So it's kind of change on top of change on top of change, which is why it's a wild ride being a web developer, as you all know. So I want to look a bit more complaining, at React without hooks, because not everyone here is a React developer. So this is just kind of a quick primer on what React can do for us and the limitations without hooks. React gives us sort of two building blocks to create our applications. The first one is function components, and the second is class components. Function components are just regular JavaScript functions, and they can take some data from a parent component through what's known as props, which is an argument into our function. And they return some JSX, which is just JavaScript masquerading as HTML. And what that does is render into DOM elements on our screen. The simplicity of this does have some drawbacks. We can't store any internal state in our function components. That's data that's internal to that instance of a component. And we can't react, pardon the pun, to lifecycle events. So a component, when it renders, doesn't know that it's being rendered for the first time or the last time or anything in between. It just knows how to render. We can sort of work around some of these issues by passing props, data and callbacks down into our function component and then running them, which affects data from a parent. But that just sort of gets really nasty really quickly, so you don't see that happening too much in a real-world application. What we have to do instead is reach for a class component, which is a bit more sophisticated. So we extend the React component class, and as you can see, we have our own state that we can use in every instance of the class component. And then we can react to lifecycle events like, hey, I've just mounted on the screen. And then we have a render function that, like our function components, returns JSX. And there are drawbacks to this approach, which is why I'm giving this talk. The first drawback is that classes tend to add bloat to our application. This nice class syntax isn't supported by all the browsers that we usually want to target. When we're releasing a web application, we want it to be used by as many people as possible, and not everyone has the latest Chrome. So we have to cross-compile down to an older JavaScript version, typically ES5, and when you do that, you get this. And you don't have to read it because there's a lot there, obviously, but there's a lot more code, and every character there is another byte the user has to download. To be fair, from the top to, that doesn't work. From the top to there, you only have to incur that penalty once, no matter how many classes you have, but then everything else, that's kind of the extra information you have to get when you cross-compile. And the more methods you have in your functions, and the more in your classes, and the more classes you have, the worse this problem gets. And that means it's going to take longer to download your application, longer for the JavaScript interpreter to chew through all that and become interactive. We have another problem, which is this. Not sure if anyone's been stung by this in JavaScript, yes?
Yes.
Yeah, oh, that thing. Yeah. So this is another class component. It has some state like before, and it has a method called showMeetup_name that just shows the name of the meetup in a standard JavaScript alert box. And then when our component mounts, we call that, we get an alert, everything's great. But we're also returning a button in our JSX, and when that clicks, we also display or call that function. And it looks like that should work, but because we're passing that through as a callback, in here, this will be undefined, and you'll get an exception, which is not what we want. And looking at this, like if you're used to a sane programming language, that would not happen. The JavaScript is not a sane programming language, so we have to deal with these idiosyncrasies. And we have to do workarounds like creating a constructor and then explicitly binding the context to this. I'm not going to go too much into it. Or we can use this new class field experimental syntax, which kind of has a lambda on the side. And I don't know why that works. I don't know why you don't need to bind when you do that. I just know you do that and you don't need to bind. But it would just be nice to not even have to worry about this stuff, right? Just lose the cognitive overhead of worrying about, oh, am I going to get undefined this somewhere? We also have wrapper hell. This affects both types of components. And this stems from a lack of ability for React to share stateful logic between components. That's things like connecting your component to a Redux store, or having like a logic where you want reusable hover logic when you hover over a component, that kind of thing. And so what you end up doing is using higher order components, which are components that wrap components. And you end up with components wrapping components, wrapping components, wrapping components, and your React component tree just gets massive, full of cruft. If you can read that, there's a whole lot of map props and context. It's not actually sort of the business logic you're trying, it's not the problem you're trying to solve, it's just junk. And hooks can help us with this. Despite all of these shortcomings, the React team is really good with backward compatibility, unlike certain other framework vendors. They've explicitly said, someone's been stung by that one. The React team have explicitly said that hooks do not deprecate classes. They're here to stay for the foreseeable future. The only caveat is that at some point you might have to add another NPM dependency to use classes, just so they can slim down the main bundle, but that's not even really on the roadmap at this point. React hooks, finally. So I guess I should tell you what hooks are. So hooks let you use state and other cool React features that we have in class components inside of our function components. So we get all the niceties that we couldn't do before in our function components, but without all of that stuff I was just whinging about. And these are pretty new. They were introduced in February for web and even more recently for React Native. So that's 16.8. I think we're only up to 16.10 at the moment, so they're still quite new, but they've already seen a lot of adoption. The first hook we'll look at, there are a lot of hooks, and I don't have time to sort of go through them all in a lot of detail, but there are a few main hooks that are the most useful ones you're going to see the most often. And the most useful and most used one of those is useState. And what this allows us to do is have state that's internal to our function component, just like we have in class components. And for this example, we're going to build this little application. It won't have styling like that, and I'm not going to account for edge cases and all that jazz. But it's a pizza ordering application which shows how many pizzas you want to order, and then there's a button which, when you click, adds a pizza to your order. We can't take pizzas away because I've never heard of anyone wanting less pizza. So we have a React function component right here, and we call the useState function. This is a React hook. React hooks are functions that by convention begin with the word use. We pass in 0 because that's the initial number of pizzas we're ordering, so it takes our initial state value. And then it returns an array with 2 items, the first of which is the current state for this particular render, and the second item is a function that allows us to update the state. So on the initial render, the state will be 0, and the way hooks work behind the scenes is, on an initial render, there's a bit of memory associated with every React component, an array, and every time it sees a hook for the first time, it will insert an entry into that array with the data for that hook, and that's how it's able to associate data with these functions. Then we return some JSX that has a label showing our pizzas, and we'll create a little callback that just adds 1 to the current number of pizzas and then sets that into the state, which effectively increases our pizzas by 1. Then we just use a callback to call our more pizza function. Note we have no this anymore because we're not using classes, so we don't have to worry about binding or weird syntax. And that's pretty much it for that. It's pretty simple once you get your head around it. When you first sort of start using hooks, especially the next hook, it's a little bit confusing and it takes a little while for it to click. But then once it does, it's a really nice experience. Oh, that's a bug. Always happens. So the way hooks are implemented, there are a few restrictions in the way we can use them. The first is that we only want to call hooks at the top level of our component. So if you try and do something like this, where we've got a hook that we're calling and another one is conditional, so sometimes it might be called, sometimes it won't. React expects them to all be called in the same order every time so that it can get the right data out of that hook array for the component. And if you did this, everything would get mixed up, so it's just not allowed. They all have to be called every time in the same order every time the component renders. And only call hooks from within React components or other custom hooks, which we'll see later. So yeah, if you try and do something like a set timeout and then call them sometime later after everything's finished, I don't even know what that would do, to be honest. Just don't do it. And you're not really going to find yourself tempted to do anything like this either. Lint yourself before you wreck yourself. Is everyone here using a linter?
Yes.
Yeah, good. Yeah. If you're not using a linter, they automatically find common problems with your code and suggest fixes for you. So you're not shooting yourself in the foot, which is easy enough to do with JavaScript, so any help we can get is appreciated. And this is an official plugin by the React team, and it enforces those rules I just went through. So, you try and call it somewhere weird, it will be an error and say, hey, you can't do that. Configuring it is very simple. You just install the package through npm or yarn, and configure it, add your plugin and your rules in your ESLint config. So there's a rules of hooks, which is the one we just covered, and there's exhaustive dependencies, which we'll see in a minute, and that one is really useful. The second hook we're going to look at is the useEffect hook, and this allows us to perform side effects after each render in our component. So side effects are things like network operations, DOM manipulation, or for this example, we're going to be rendering to a canvas. So again, we have a function component. This time, we're taking data as props from a high-level component, and I'm just doing that because I don't have that much screen real estate. It could be internal state as well, but in this case, we're assuming that there's some parent component that's managing that data for us. We return null in this case because, for this example, we're assuming this canvas already exists and that we're going to have a third-party library that kind of knows about it, knows how to draw to it. And so there's no actual DOM content being returned by this, which is fine. We call the useEffect function, which runs after every render. So you can do this sort of thing with class components, but that runs synchronously during your render. So if you're doing anything sort of computationally expensive, it will hold up the render cycle, so things will get sluggish, whereas this waits for things to render and then runs, which is a bit nicer. And we have this canvas lib, just an imaginary library that knows how to draw a circle. And so every time it renders, it will look at the X, Y, and radius props, and we'll get a circle on our canvas, which is very cool. So that's our first render, but there is a problem. On our second render, we get props changing, we draw another circle, but we haven't cleared the old one, so we're just going to get more and more circles, which isn't really useful. And useEffect caters for this really nicely by letting us return a cleanup function. So the way this works is, before the effect runs on every subsequent render, it runs this function to clean things up, and then the new props are passed into the effect, and then that gets called, which we'll look at again in a second. But there is one issue with this still, and that is that if the only thing that changes in our props is the name, that doesn't really have anything to do with our circle. We only need the x, y, and radius when we're changing the circle. And for a circle, this might not be a problem, but if you're doing something that is expensive to compute, you really want to restrict your renders to only happen when they absolutely need to. And to solve this, we can pass a second argument into the useEffect hook, which is a dependency array. And that contains everything that is affected or used by our effect. And this is kind of similar to useState. The first time this hook runs, it will insert entry into the hook's array, and it will insert those values. And then on a subsequent render, it will compare the new props, so the new XY radius against the old XY radius, and if any of them are changed, then the effect and the cleanup run, and if not, they don't run. So going through this from the top, before our component mounts, we just have an empty component. On the first render, we draw our circle, then sometime later we get a prop update, and because our dependency list has changed, because our x, y, and radius have changed, that triggers the cleanup function to clear the canvas, and then it's redrawn with the new values. Then again we get another update, but this one only updates the name, because our dependency array remains the same between the previous props and the new props and doesn't render. And then finally, when the component unmounts, maybe the user navigated to a different page or whatever, that runs the cleanup function one more time. This is where that second ESLint rule comes in really useful, the exhaustive dependencies. It's really common when you're trying to optimize performance to forget something in this dependency array. So if we forget, say, to put the radius in there, which we need, if the radius is the only thing that updates on a given render now, this won't run because the dependency array has changed between both. And the really cool thing is that this ESLint rule will actually do static analysis of the contents of your hook and figure out for you what the dependencies are. And then it will tell you, hey, you're missing radius. And then even better, you can fix it. So it'll tell you what to do, and then you can just click it and fix it. And when I started writing these, I thought, I know better than you. I'm like, you don't need that in there. And then every single time there'd be a bug. Okay, damn, everyone's smarter than me. So, surprise. So from now on, I just obey. As soon as it says, hey, you need this in there, I say, okay. And my bacon has been saved many times. Now that we've seen the two major hooks, we can look at how we can compose this into our own custom hooks, which is kind of replacing the role of all that wrapper hell components on top of components, because now we can reuse stateful logic. So for this example, we're going to be building ogle search. So we have an input that we can type a query into, and then we display results at the bottom, just in JSON because I'm lazy. So I've already implemented this one because it's nothing we haven't seen before. We have two pieces of state. We have a query, and we have results. It could just be one useState call that takes an object, but again, I'm just keeping it simple. We have a useEffect hook that updates, that runs whenever the query changes. We're going to go query in the dependency list, and that will call the ogle search API with our query string, and then when the results return, they will be set into the results state. And then we just have a change handler that we bind to the button, to the input, so that whenever the user types, it will update the query, which will cause the effect to run. This is kind of where it gets a bit, you need a different mindset with hooks, because you're sort of not running query directly, you're updating the state, which triggers an effect. And that's the part that takes a while to sort of wrap your head around sometimes. But what we're going to do, the focus of this is we want to extract this logic into a reusable hook so that we can apply this to different areas of our application. And I was kind of blown away by this. I thought there'd be all custom special code to handle this, but there's literally none. All we do is create a function, and then we take all this hook stuff and throw it in there, no changes. And then we return the bits that we want to expose to the caller. And then in our component, we call our new hook and grab the bits out, which are what we had before, and that's it. There's zero custom code in the React code base to handle this because we're not violating the rules of hooks. Every time this Opal search bar function renders, it calls the use Opal search function, which then calls all the hooks in the right order. So all the rules of hooks are being obeyed, and that's all you need to do when you create custom hooks. Which, yeah, I was kind of blown away by that. It's really cool. The third hook we'll look at is use context, and this one is reasonably straightforward. It just lets you share a value from a certain part of your component tree with all the children beneath it. This is really useful for things like theming. So we have a React context, which existed before hooks, just the API's been made nicer now. And a context just holds a value and lets you provide it to the children in the tree. And so we use the theme context provider as a component and pass in an initial value, which we're imagining we have like a dark theme versus a light theme. And then we have a bunch of nested children and a child component, which is declared down the bottom here, and we use the use context hook. And the way this works is from our child, it will crawl up every parent recursively until it finds a matching provider for that value. If it doesn't find a provider, it just returns undefined. And then I'm just styling a div to be a certain background color depending on the theme. And because every time your context value changes, it will automatically re-render anywhere that's using that context, you can make it really simple to theme your application. You can just provide a way to update that context value, and it will automatically apply across your whole application anywhere that uses the context, which is pretty sweet. We have a few other useful hooks. I'd like to go into detail with them all, but I don't want to keep everyone here all night. So we have use reducer, which is kind of, it's basically a Redux implementation using hooks. I've actually replaced Redux with this in my own applications. It's really nice. It's not quite as sophisticated as Redux in terms of being able to map a subtree of your Redux store to components for performance reasons. But if you've sort of got an application where each screen can have its own reducer, which I have, it works great. We also have use callback and use memo, which are basically just for performance purposes. So looking at use memo, if you have some value that you need to compute on a re-render and it's expensive to compute, you can restrict it so that we'll only do that computation when the dependencies change. So it's basically like use effect in that we have this dependency array, and whenever that array changes between your renders, it will recall your expensive function and spit out the value, as opposed to doing that every single render. And use callback is exactly the same, except it returns a function instead of an object. There are also tons and tons of third-party hooks out there already. There are a lot of collections. This is one I quite like, and it has them categorized into different groups. This is a sensors group, so if you want to interact with various sensors in your device, especially mobile devices, things like battery, location, and there's other things like media queries or orientation, all sorts of things. You can just go and grab these pre-baked hooks and toss them into your application. So next steps, I'll leave you with this. I have 4 pieces of advice if you want to start looking at hooks. The first thing you should do is spend a couple of hours going and reading the official documentation, because it's really good. You would have been well served if I just spent this half an hour just putting the documentation up there and you read, to be honest. And it goes into more detail than I could ever fit into a half-hour talk. Motivation for hooks, when to use them, when not to, things to look out for. So if you're going to invest a significant amount of effort into rewriting your application with hooks, you should know how to use them. Secondly, set up the ESLint plugin. Do it. You won't regret it. And don't start with the nervous system of your application. Try and find a simple thing to start on, just to get comfortable with it, dip your toes in the water. Ideally, if you have a class component that just uses a little bit of state, that would be a great place to start. And then slowly work up in complexity until you can tackle that nervous system. And finally, similarly to ESLint, you should definitely look at using TypeScript. Probably not learning it at the same time as hooks, but at some point look into it, because that, much like ESLint, prevents you from a whole class of errors in your application. And you have really good typing for things like use state and use context that just prevent you from sticking the wrong types into things. So that's all from me. Thanks for listening. Any questions?
About use context.
Yep.
In terms of rendering, so if you change the top level context, is that re-rendering the entire application below it, or just the things listening to that context?
Yeah, well, effectively React always renders the entire application, but it goes through its reconciliation. It will only sort of fully re-render the things that need to.
Change props.
Yeah. So, yeah, essentially it's only going to do the things that are affected by that.
Okay.
Yep.
Do you use ESLint in TypeScript?
Yes, not as opposed to TSLint.
Yeah.
Yeah, so ESLint is the recommended going forward. I think they're deprecating TSLint.
Yeah, does that happen? Like, because I was always confused. Like, I go on there and it's like, TSLint, what do you do this now? And I can't work out how to do it.
Yeah, I think they've realised that ESLint's been built better than TSLint. I think that's why. I could be wrong, so no offence to any of the TSLint developers if you're watching. Yeah, I think they've figured, like, why bother duplicating all this effort when they're basically the same tool.
They did like a big announcement, we're all going to ESLint now, but
Yeah.
then like, I don't know how to go to ESLint.
Yeah, I think I just sort of, I just took the standard, like in the React Star, and went with that. Anyone else?
Exhaustive depth. What about the situation where you just want it to run on the first render and you just want to give it like an empty?
Yeah, that's a really good point. I was going to include that in the talk, but I was like, oh, it's already half an hour. Yeah, so if you only want your effect to run once on mount, and then you want it to clean up on unmount, you provide an empty array as a dependency array. That's kind of the special case in React.
But then you'll still get the ESLint warning, so right?
No, you won't if it thinks that you don't need any dependencies. So if you know better than them, what you can do, because ESLint will only lint your code, not third-party code. So if you go to that ESLint collection that I just showed, it has a use on mount and use on unmount hook. And so you can use that as a workaround, so that does the same thing, just provides an empty array, but it just won't get linted.
You just ESLint ignore line.
Yeah.
That's messy.
Yeah.
So it's messy.
You're telling
Yeah.
me
As
to lint
another
it.
other one of the dependency, I sort of jumped through.
Yeah, but that exact thing, I thought that too. I was like, I don't need to do this anytime, just on mount and unmount, but it turned out I did, and it saved my mate. So, yeah, you have to be careful to go against your unit for a good reason.
Sorry, the dependencies, they have to be primitive because we're checking the change state of that guy.
Yeah, so if you're redeclaring an object every render,
Yeah.
that's right.
So because it's because it's passing by reference the object. So
Yeah, that's
you-
exactly
yeah.
right. So you have two options there. You can either destructure your object into all the fields that you want to add into that array, or you can use that use memo callback, which will return the same object every time until the affected props change.
Oh right.
And,
Okay.
and the same, you can have a
use his image.js talk from last time.
yes, that's right. And that's what the use callback, because you can have functions as a dependency in your effects as well. And use callback is just use memo for functions. So yeah, because every time you declare a function, it has a different identity between renders.
Yep.
But that will return the exact same function object until your dependency list changes.
Oh right. Okay. Yep. Cool.
Good question.
Yeah, and likewise, if you have a callback that mutates something that's a dependency, then it won't be rendered.
Yeah.
So you want to
You just want to not mutate wherever possible. Yeah.
Cool. Yep. All right. Round of applause for Chris.